All right, so here's our problem. We have a 792 inch cable. The cable weighs 68 ounces for every 6 inches of cable. How much work is done to wind up 2/3 of the cable? All right, so here's our winch, and then we have our cable. So first we have to do some unit conversions. So first we have to find the length of the cable. 792 inches divided by 12 inches per foot equals 66 feet. And then to figure out F, which is the weight of the cable per foot, we need to do F equals 68 ounces per 6 inches, right? So we need to convert that into pounds for feet. So there are 16 ounces in a pound. So first you've got to take 68 and divide it by 16, and that gives you 4.25. And now since that's the weight for 6 inches of cable, and there's 12 inches in a foot, we have to multiply that by 2 to get the amount per foot. So our final answer would be F equals 8.5 pounds per foot.
So, using our unit conversions, we know that the length of the cable is going to equal 66 feet. However, we're not winding up this entire cable, so around down here will be our X. All right, so our next step in this problem would be writing out our distance, which is D equals 66 minus X. So now we can go out and head and find our work. So W equals 8.5 integral of 66 minus X dx.
Yep.
All right, so now we have to find our limits for our work problem. So we know that the cable is only going to be wounded up 2/3 of the cable, and the length of the cable is 66 feet. So we can write out 2/3 multiplied by 66 feet is going to equal 44. So from here to here will be 44 feet. And now, since we know we're going from, just cut it. So since we found our limits, we know that it is only be wound up from 0 to 44, which is right around there. Now we can plug it into our calculator and find the work for the problem. So we got around W equals 16,456 feet times pounds. And that is our answer.
This is a winch, and this is a cable, and you use a winch to to wind up the cable. See how the cable's going into the winch? That's what you use a winch for.